Alright, today we are going to be talking about trigonometry some more. Alright, so I put this up all these notes in just for your reference. You can look at this. If you're looking at a 45-degree angle, you can see that sine of 45 is 1 over the square root of 2, 1 opposite over hypotenuse. And then they have to rationalize it, which would be the square root of 2 over 2, which again is right there. Sine of 45 would be the y-coordinate. Cosine would be the x-coordinate, square root of 2 over 2. Okay, same thing with the 30 degrees and the 60 degrees. Like I said, the sooner you memorize this unit circle, the easier finding these things are going to be for you. Alright, so it says, find the acute angle that satisfies the given equation. Give theta in both degrees and radians. You should do these problems without a calculator. So you have a couple of ways to approach this. You can, without a calculator. If they're saying do this without a calculator, then I promise you theta is in the unit circle. Okay? I'll show you how to do these on a calculator later, but right now they want us to do it without a calculator. So what you're doing, you have a couple of choices. You can look for an angle, either the 30, the 60, or the 45, that has this opposite over adjacent. So you can use the triangles, or you could use the unit circle. Okay? I'm going to use the triangles. I know that sine is opposite over hypotenuse. So I'm looking for a side that's 1 and a hypotenuse that's the square root of 2. Well, the only one that has a hypotenuse of the square root of 2 is the 45, 45, 90. So this would be opposite. This would be hypotenuse. So theta equals 45 degrees. And in radians, that would be pi over 4. Okay? You could do the formula if you wanted to convert degrees to radians, and that would work, but you don't need to. In a 30, 60, 90, again, get used to using the unit circle. It makes life a lot easier. You don't have to do the math. Okay, right here in the unit circle, you can see there's the degree measure, there's its corresponding radian measure. Okay, cotangent. Cotangent is adjacent over opposite. So I'm looking for the square root of 3, which tells me I'm in the 30, 60, 90 triangle. And that has to be opposite of whatever the angle is. So the square root of 3 is opposite of the 60, and 1 is adjacent to it. So adjacent to 60 is 1, opposite of 60 is the square root of 3, so theta equals 60 degrees. And again, you can go to the unit circle. 60 degrees in radians is pi over 3. All right. Cosecant. You need to make these a fraction. If they're not, they're easier to read if you do. Okay. Cosecant is hypotenuse over opposite. The only hypotenuse that has a square root of 2 is the 45, 45, 90 degree. So I need the hypotenuse to be the square root of 2 and opposite to be 1. And either one of these would actually work. If I'm going to do this angle, it would be, there's my opposite, there's my hypotenuse, right? So cosecant, that theta would be 45. Even if you did up here and said, well, this is opposite of this side, and this is hypotenuse, that's still, remember, in a 45, 45, 90, the other angle is 45 degrees also. So in this one, it wouldn't matter where you stood. And in radians, 45 degrees is pi over 4 radians. Okay, sine again is opposite over hypotenuse. So this one, I'm looking for a hypotenuse of 2. Well, I don't have a hypotenuse of 2 over here. All of my hypotenuses, oh no, this one is a hypotenuse. There's my hypotenuse of 2. Okay. So hypotenuse is 2 and opposite is 1. So I can't use the 60 because opposite of 60 is the square root of 3. The one that's opposite, that's 1 is opposite of the 30 degree. So I want opposite is 1 and hypotenuse is 2. So my theta would be 30 degrees. And in radians, that would be, oops. Sorry. In radians, that would be pi over 6. Okay. Alright, so you do this one. Hit pause, come back when you're ready. And hopefully you got 60 degrees. Alright, they're giving me tangent theta equals the square root of 3. And I put that over 1. Tangent is opposite over adjacent. So I need the square root of 3 to be opposite of something. And square root of 3 is opposite the 60. And adjacent is 1. Can't be, I mean, you're going to say, well, 2 is adjacent to. How do you know it's the 1? 2 is the hypotenuse. You can never call it adjacent or opposite of anything. It's got to be called the hypotenuse. So, my theta would be 60 degrees. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 30 degrees. So they gave me cosine of theta equals the square root of 3 over 2. Cosine is adjacent over hypotenuse. So I need the square root of 3 to be adjacent, whatever it's adjacent to. Well, square root of 3 is adjacent to the 90, which we can never use, and it's adjacent to the 30. And hypotenuse is 2. So this is adjacent, and this is hypotenuse to this angle. So theta would be 30 degrees. Okay, so this one said, oh, hit pause. Come back when you're ready. And hopefully you got 45. It tells me that secant theta is the square root of 2. This, by the way, means, this says that theta has to be between 0 degrees and 90 degrees. So you're looking in for an angle in this quadrant. In other words, you don't care. It can't be, they're limiting you to just the first quadrant. Okay? That's what that means. Secant is hypotenuse over adjacent. So I need a hypotenuse of the square root of 2, which is that one, which means theta has to be 45 degrees. Okay? Alright, we're going to be learning how to solve a right triangle now. And to solve a right triangle, they've got to give you a couple of pieces of information. And then with those couple of pieces of information, we're going to find all the rest of the trig functions. Alright. So, oh, sorry, we're not going to solve the whole triangle yet. They're going to put certain information in and tell us to find, this one says solve for the variable shown. So we're trying to solve for x. You have to stand at the angle that they gave you. I mean, you can either stand here or here because those are the two acute angles. I don't want to stand here because I won't have enough information. They didn't give me this angle, so I don't want to stand there. They gave me this angle, so that's where I'm going to stand. And from this perspective, 41 is opposite, x is adjacent, and what function uses opposite and adjacent is cosine. So I would say that cosine of 57 degrees is equal to adjacent is x and opposite is 41. So I set up my equation and then I solve it for x. So to get x alone, I'm going to multiply by 41 on both sides. That cancels it. And x equals, and you're going to type it in. Make sure that you're in the right mode. Right now I need to be in degrees because my angle is given in degrees. So change your mode to degrees, and then you type 41 times cosine 57, and you get 22.33. So x would be approximately 22.33020044, whatever. Okay? So if we do this one, this is the angle they gave me, so this is where I'm standing, and from where I'm standing, this is the hypotenuse, and this is opposite. The function that uses opposite and hypotenuse is sine. So I can solve this by doing sine 26 equals opposite over hypotenuse. Again, to get x alone, we're going to multiply both sides by 2, making sure we're in degrees again. So 2 times sine 26, and you get 0.8767. Okay? Yeah. Hold on, let me just check one thing. Yeah. Alright, so this side would be approximately 0.8767. Alright. Solve this one, hit pause, come back when you're ready. And hopefully you got 21.76. There's the angle they gave me, so that's where I'm standing. From where I'm standing, this is opposite. This is adjacent. That's tangent. So tan 52 equals x over 17. To get x alone, I'm going to multiply by 17. And I get x equals 17 times tan 52 is 21.759, blah, blah, blah. And they said rounded 2 decimal places, so that bumped it up to a 6. Alright, you do this one, hit pause, come back when you're ready. And hopefully you got 15.97. Again, they gave me this angle, so that's where I'm standing. From where I'm standing, x is adjacent, 17 is hypotenuse. Adjacent and hypotenuse is cosine. So cosine 20 equals adjacent over hypotenuse. And to get x alone, you're going to multiply both sides by 17. And x equals 17 times cosine of 20. And you get 15.974. The 4 isn't going to bump it up, so it's 15.97. Alright, solving a right triangle. It says a right triangle with a hypotenuse of 8 inches, a 37-degree angle. A hypotenuse of 8 includes a 37-degree angle. Find the measure of the 2 other angles and the length of the other 2 sides. When you're solving a right triangle, in the end, you need angle A, angle B, angle C, little a, side B, and side C. We use capital letters for angles and lowercase letters for sides. Let's get what we know. If this is little a, then this is capital A. Your angle, capital letters always across from or opposite of the side A. So this would be big B, and this would be C. So I know C is 90 degrees. They told me that. I know that A is 37 degrees. They told me that. And I know that little c is 8. Across from big C is little c. So I've got to find 3 other pieces of information. Now you can use trig, and sometimes you have to find the angles. But the easiest way to find a missing angle, when you know the other 2, is to take 180 minus 90 minus 37, because there's 180 degrees in every triangle. So 180, take away 90, take away 37, leaves 53. So B has to be 53 degrees. And I can label that. So now I got to find the other 3 sides. To find the other 3 sides, you can, now that you know all 3 angles, it doesn't matter. You can stand at A or you can stand at B. I like to stand at the angle that they provided in case I screwed that up somehow, like hit a wrong button or something. So let's see, I need to find A, which is opposite of where I'm standing. I can't, this is adjacent to where I'm standing. I can't use opposite and adjacent because those are both letters. This is hypotenuse. I need to use one thing I don't know and one thing I do. So I'm going to use opposite and hypotenuse, which would be sine. So if I sine my 37-degree angle, I can set up opposite over hypotenuse. And to solve for A then, I would multiply both sides by 8. So I have 8 times sine 37, and I get 4.8145, yada yada yada, equals A. So little a is 4.81. I don't know how many decimals they want us to go out. I'm just going to go out 2 decimals for now. If they tell you, they'll tell you on Math Excel how many places they expect you to go out. So little a is 4.81. So now I got to find little b. Well, little b is adjacent to me, And again, I could use this now. I could do adjacent and opposite and do tangent. But I like to use, anytime I can, I don't like to use numbers that I calculated, again, in case I made a mistake. So I want to do adjacent and hypotenuse. Adjacent and hypotenuse is cosine. So if I do cosine 37 degrees, that will equal adjacent, which is my little b, over hypotenuse, which is 8. And I can solve for b by multiplying both sides by 8. So I get 8 times cosine 37, and I get 6.39 if I round equals b. So now that I know all 6 sides, I'm done. That I've solved the right triangle. Again, now guys, you could use other functions. I mean, there's nothing that says I had to do sine and cosine. I could have actually done, and let me just prove it to you, I could have done tan 37 equals opposite, which is my 4.81, over my adjacent, which would be b. If you did that, if you set that one up to solve, it would work. You'd have to multiply both sides by b, so that I have b times tan 37 equals 4.81, divide by tan 37, and I can get little b. I would type in 4.81 divided by tangent of 37, and I get 6.38308, blah, blah, blah. And again, it's not because of rounding. It's not exact, but it's pretty darn close, yeah? Alright. So you do this one, hit pause, come back when you're ready. And hopefully you got 4. Alright, so let's see. We need, if we're solving the right triangle, we need angle A, angle B, angle C, side A, side B, side C. If I fill in what I know, they told me little c is 19 and big B is 16 degrees. So I know B is 16 degrees, I know that C is 90 degrees, and I know that little c is 19. They've got to give you 3 of the 6, okay? So the first thing I'm going to do is find my missing angle, which I can do by doing 180 minus 90 minus 16. And I get 74 degrees. Okay, so now I know this angle. Alright, so depending on where you want to stand. Again, you could go up and stand at the 74 degrees and then use that. Me personally, I'm going to stand at the angle that they gave me, because then I'm not relying on my calculations. Alright, so if I stand there, and I'm looking for B, that would be opposite of me. This is hypotenuse, and this is adjacent. So let's see, if I do opposite and adjacent, that would be tangent, but this doesn't help me, because if I do tan 16, that would be B over A. I have 2 letters in that equation, and that algebra doesn't work then. So tangent, if I knew one of those pieces would work, but since I don't know either one, I can't do tangent. So if I choose to do opposite and hypotenuse, because there's one I don't know and one I do know, opposite and hypotenuse would be sine 16 equals opposite over hypotenuse. So then to get little b alone, I'm going to multiply by 19. So I have 19 times sine of 16, and I get 5.23, b equals 5.237, yada yada yada. And it says to the nearest tenth, so I only go out one place, which means b is 5.2. So now I know that. Alright, and I need to find little a. Again, just to show you, I mean, I would stick with staying at the 16, and I would use adjacent and hypotenuse, which would be cosine. But you wouldn't have to. You could go stand up here if you wanted to. And from here, I'd be looking for opposite, and I could use hypotenuse, and then I could do sine again. It doesn't matter. Once you start filling in the pieces, you'll get the same answer, even if you move. Alright, but I'm going to stick with staying down here. So I'm going to do cosine of 16 degrees equals adjacent over hypotenuse. So to get little a alone, I'm going to multiply both sides by 19. And little a would be 19 times cosine 16. And I get little a is 18.26 to the nearest tenth. That would bump that up to 18.3. So there's the 3 pieces that I was missing. Okay? Alright. You try this one. Come back when you're ready. And you should get that. Ew. I don't really like how they did the degrees, but anyway. Alright, I need angle A, angle B, angle C, side A, side B, side C. They give me little a is 18, and they give me this angle is 71 degrees, 40 minutes. Well, let's see, so I know this is 71 degrees, 40 minutes. C is 90. C is 90. So, when you're in degrees and minutes, okay, if I take 180, take away 90, that would leave 90. If I take 90 and I subtract 71 degrees, 40 minutes, well, to get to the next degree, I would need to add 20 minutes, which would give me 72 degrees, right? And if that was 72 degrees from 90, that would leave 18. So we would have 18 degrees, 20 minutes is how they got that. Okay, now my problem here is when you do trig, you can't use degrees and minutes. You're going to have to convert them all to degrees. So if I take 71 degrees, 40 minutes, and I divide this by 60, 40 divided by 60, I get 71.6 repeating degrees. Okay, so I need to use all degrees when I'm doing my trig. Alright, so if I'm standing here, I know opposite, and I'm looking for hypotenuse and adjacent. Alright, so if I want to find adjacent from standing there, the only thing I know opposite, and I'm looking for adjacent. Opposite and adjacent is tangent. So I would set up tangent of 71.6 repeating degrees equals opposite, which is 18, over adjacent, which is B. So now if I solve that, I'm going to multiply both sides by B. That gives me B times the tangent of 71.6 equals 18. To get a B alone now, I'm going to divide by tan 71.6. And little b then is going to equal 18 divided by tangent of 71.6. And I get little b equals 5.987 blah blah blah, nearest tenth. Right here. The 8 would bump that up to 10. Carry the 1 would make that 6.0. So there's where they got the b is 6. Alright, so now to find C, again, if I want to stay standing here, if I'm looking for C and they gave me opposite, I'm looking for opposite and hypotenuse, so that would be sine. So sine 71.6, repeating, equals opposite, which is 18, over hypotenuse, which is C. So to get little c alone, I'm going to multiply both sides by C. That gives me C times sine 71.6 equals 18. So now to get C alone, I'm going to divide by sine of 71.6. Cancels that, and C equals 18 divided by sine 71.6. And I get 18.969. Again, rounding, 6 bumps that up, carries. Alright, and I end up with 19.0. Okay. Alright, so given an angle, and I spelled that angel, Given an angle of a right triangle, how do you find the 6 trigonometric values? Oh, I should say given an angle on the side, how do you find the 6 trigonometric values? Well, you set up the triangle, label, and then set up the correct trig function to find the missing angle. And again, it's hard to be real specific on this because it depends on what you're started off given. Alright, so it says finding the height of a building. From a point 340 feet away from the base of a Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65. So if you're standing here and you're looking up, this would be your horizon, looking straight across out your eyeballs. To look up to the top, that angle would be 65 degrees. And it tells me that there's a point where you're standing is 340 feet away from the side of the building. And they want us to find the height of the building. So if I'm standing here, this is opposite, this is adjacent, this is hypotenuse. Well, I'm looking for opposite, and they gave me adjacent. Opposite and adjacent is tangent. So what I'm going to set up is tangent of 65 equals h over 340. So to figure out the height, I'm going to multiply both sides by 340. And the height of the building, if I take 340 times 10 of 65 degrees, I get 729.13, and what are we in feet? So that building is 729 feet tall. Alright, this one says a police helicopter is monitoring the speed of 2 cars on a straight road. So you've got a car here, and you've got a car here. Don't make fun of my car. Okay. It says the helicopter is at an altitude of 4,200 feet directly above the road. If this is a road, directly above, this would be where my helicopter is, and that's 4,200 feet off the ground. At one instant, the angle of elevation from the first car to the helicopter is 20 degrees. Oh, sorry. Here's my first car, so that's going to be 20 degrees. And it says the angle of elevation from the second car to the helicopter is 16 degrees. How far apart are the 2 cars to the nearest foot? Alright, so we've got ourselves a little bit of a dilemma here. What I'm trying to figure out is this distance right here. How far apart are the cars? Well, would you agree that if I could find this whole green line and then just subtract off this much, the blue part, wouldn't I end up with, in green, that's all of the part of the green that I want? Exactly. So, let's work on finding the green line, which means I'm using this great big triangle, okay, which has an angle of 16 degrees. And let's see, I know that I can find this distance, right? But because if I'm standing here, or the car is, this would be opposite, this would be adjacent, and I'm trying to find adjacent. So I would do opposite and adjacent would be tangent. So tangent of 16 equals 4,200 over, I don't know, what do you want to call it, x? Okay, so to solve this, I'm going to have to multiply by x. That gives me x times tan 16 equals 4,200. To get x alone now, I'm going to divide by tan 16. And x equals 4,200 divided by tangent of 16. And I get 1,000. Okay, 14,647 0.14 feet. Okay, so that's the big green one. Now, let's figure out what this blue one is. And the blue one, I'm just going to use the small blue triangle, which again, I know the opposite, and I'm looking for the adjacent, but now I'm just looking for this adjacent part. Again, the opposite and adjacent is tangent, so I set up tangent of 20, because the angle is different now, equals 4,200 over, let's call this y. I don't want to call it x, because that would indicate that it's the same length as the other, and it's not. So to solve this one, I'm going to multiply by y. So I have y times tan 20 equals 4,200. Divide by tan 20. And y equals 4,200 divided by tan 20. And I get 11539.41. Alright, so that's the little blue part. So if my plan was to take the green, which was 14647.14, and subtract the blue, so minus 11539.41, and 14647.14 minus 11539.41, I get 3,107.7 feet. These cars, that distance right there, the cars are that many feet apart. Okay? Alright, so you try this one, hit pause, come back when you're ready, and hopefully you got 32. A kite is currently flying at an altitude of 16 meters above the ground. So here's your kite, right? And you got this string going somewhere. And if I dropped an altitude, okay, it says that this kite is 16 meters above the ground. The angle of elevation from the ground to the kite is 30 degrees. Find the length of the kite string. This would be the kite string. Okay. So from the 30 degrees, they gave me opposite. They want hypotenuse. That's a sine function. So I would do sine 30 equals 16 over x. And again, now to solve for x, I'm going to multiply by x. Gives me x times sine 30 equals 16. Divide by sine 30. And I get x equals 16 divided by sine 30. And I get 32 meters. Yeah? That's the length of the kite string. Alright. You try this one. Hit pause. Come back when you're ready. And hopefully you got 31 feet. Says to measure the width of a river, a surveyor starts at point A on one bank and walks 74 feet down the river to point B. So they're telling you that distance is 74. He then measures angle ABC, which means angle B, whatever's in the middle is the angle they're looking for, to be 22 degrees, 32 minutes, and 12 seconds. Estimate the width of the river to the nearest foot. So this is the width of the river would be the distance between. That's what they're looking for. Okay? So from here, if I'm standing here at the angle they gave me, I'm looking for opposite. They gave me adjacent, so I'm going to use tangent. The problem is I've got to convert. Okay? So if I do 12 divided by 60, I get 0.2. So now I have 22 degrees and 32.2 minutes. Divide that by 60, 32.2 divided by 60, and I get 22.54 if I round degrees. So I'm going to do 22.54 degrees equals opposite over adjacent. And so to get x alone, I'm going to multiply by 74. So I have 74 times tan of 22.54 degrees, and I get x equals 30.71 blah blah blah, and it said to the nearest foot, so 7 bumps it up, bumps the 0 up to a 1. Alright, so how do you solve application problems involving right triangles? Well, you either label the diagram or draw your own. Draw diagram. Oh, diagram. No, don't draw a diagram. Draw your right triangle. Make it look like a right triangle. Label it. Label with info given. And then set up the correct trig function to find missing info. Alright, 5 says, what is the limit as theta approaches 0 of sine theta? It says, use diagrams and several examples to explain your answer in terms of right triangles in which theta gets smaller and smaller and smaller. I said, hint, choose several values for theta from 89 down to 0. Draw the triangle and calculate cosine theta. Not cosine, should be sine, because I'm doing sine. Okay, so do sine theta. Then make a table of values to justify your answer. So, like I said, you might do sine of 89 degrees. Then do sine of, they want you to get smaller, so maybe do 70. Then do sine of maybe 50. And then do sine of maybe 20. Sine of 10. Sine of 5. Sine of 2. Whatever. Just do a couple till you start seeing the pattern. And that's what they want you to find. As you pick smaller and smaller values of theta, what's happening to the value of sine? Is it going up or is it going down? That's what they're trying to get you to see. Alright, so we are at homework, which means we are done. So happy homeworking, and I will see you next time.